Mercury is the smallest planet in our solar system. Despite its size, it holds many secrets and mysteries that continue to intrigue scientists and astronomers alike. It's also the closest planet to the Sun, making it a unique subject of study due to its proximity to our star. This tiny world is a fascinating place. Its surface is covered with craters, much like our Moon, giving it a rugged and ancient appearance. It's a rocky, terrestrial planet, composed mainly of iron and nickel. The surface is marked by vast plains and towering cliffs. Mercury has a very thin atmosphere, almost non-existent. This exosphere is composed of atoms blasted off its surface by the solar wind and micrometeoroid impacts. This means there's no air to breathe and very little protection from the sun's intense heat and radiation. The lack of atmosphere also means that the sky is always black, even during the day. Mercury has a unique relationship with the Sun. Its elliptical orbit brings it as close as 29 million miles to the Sun and as far as 43 million miles. It orbits the Sun much faster than any other planet, completing a full orbit in just 88 Earth days. A year on Mercury is only 88 Earth days long. This rapid orbit is due to its close proximity to the Sun, resulting in a strong gravitational pull. This speedy orbit, combined with its slow rotation, creates some extreme temperature differences. One day on Mercury, from sunrise to sunrise, lasts about 176 Earth days. Mercury's surface is a harsh and unforgiving environment. The planet's slow rotation means that one side is exposed to the sun's heat for long periods, while the other side remains in the dark. Temperatures can soar to 800 degrees Fahrenheit or 430 degrees Celsius during the day. This intense heat is enough to melt lead, but at night they plummet to minus 290 degrees Fahrenheit or minus 180 degrees Celsius. This drastic drop occurs because there's no atmosphere to retain the heat. This extreme temperature swing is the largest in our solar system. Despite these harsh conditions, Mercury remains a subject of great interest, offering clues about the formation and evolution of our solar system. Observing Mercury from Earth is a challenge. This small, rocky planet, the closest to the Sun, presents unique difficulties for astronomers. This is because it's so close to the Sun. Its proximity means it is often lost in the Sun's bright glare. The Sun's glare makes Mercury difficult to spot in the sky. The intense brightness of the Sun can overwhelm the view, making Mercury appear almost invisible. Ancient astronomers struggled to track its movements. They had to rely on rudimentary tools and their keen observations to follow Mercury's path across the sky. Even with powerful telescopes, it's difficult to get a clear view of Mercury from Earth. The planet's small size and rapid orbit around the Sun add to the challenge. Another challenge is Mercury's small size. It's the smallest planet in our solar system, even smaller than some of the moons of other planets. It's only slightly larger than our moon. This makes it appear as a tiny dot in the vast expanse of space. This makes it appear as a small dot even through telescopes. The planet's surface details are hard to discern from such a great distance. Despite these challenges, astronomers have been fascinated by Mercury for centuries. Its rapid orbit and unique characteristics have made it a subject of intrigue and study. They've developed clever ways to study it from afar. Modern technology, including space probes and advanced telescopes, has provided new insights into this elusive planet. One way is to observe Mercury during twilight. This brief period offers a unique window when the planet can be seen without the overwhelming brightness of the Sun. This is when the Sun is below the horizon, but the sky is still somewhat bright. The reduced glare allows Mercury to shine more clearly against the twilight backdrop. During twilight, Mercury is visible for a short time, and the Sun's glare is less intense. This fleeting moment is a prime opportunity for astronomers to capture images and gather data on this mysterious planet. To truly understand Mercury, we needed to send spacecraft there. In the 1970s, NASA launched the Mariner 10 mission. This was the first spacecraft to visit Mercury. Mariner 10 made 3 close flybys of the planet in 1974 and 1975. Mariner 10 sent back the first close-up images of Mercury's surface. These images revealed a heavily cratered world, similar to our Moon. Mariner 10 also discovered that Mercury has a surprisingly strong magnetic field. This discovery was unexpected. Scientists had thought that Mercury's small size meant its core had cooled and solidified long ago. A molten core is necessary to generate a magnetic field. Mariner 10's discovery challenged this assumption. Mariner 10's flybys were brief, but they revolutionized our understanding of Mercury. The spacecraft only managed to image about 45% of the planet's surface. Despite this limited view, Mariner 10's data revealed a world of surprising diversity. The images showed vast plains covered in volcanic material. These plains suggested that Mercury had experienced a period of intense volcanic activity in the past. Mariner 10 also found evidence of cliffs, some hundreds of miles long and soaring up to a mile high. These features, called scarps, are thought to have formed as Mercury's interior cooled and contracted. This contraction caused the planet's surface to wrinkle and crack. Section 5. Messenger Unraveling Mysteries. In 2011, NASA's Messenger spacecraft entered orbit around Mercury, marking a significant milestone in space exploration. This was a major achievement as it was the first spacecraft to orbit the innermost planet of our solar system. Mercury's proximity to the Sun makes it a difficult target for spacecraft due to the intense heat and gravitational pull. Messenger's mission was to build upon the discoveries of Mariner 10, which had flown by Mercury in the 1970s. Over the course of 4 years, Messenger orbited Mercury, meticulously mapping its entire surface in unprecedented detail, revealing features never seen before. It also conducted extensive studies of the planet's magnetic field, thin atmosphere and unusual composition, providing valuable data to scientists. One of Messenger's most surprising discoveries was the presence of water ice, a finding that challenged previous assumptions about the planet. The ice was found in permanently shadowed craters at Mercury's poles, where temperatures remain extremely low. These craters are incredibly cold even during the day due to their lack of direct sunlight. The discovery of water ice on Mercury was unexpected and sparked excitement among scientists as it opened new avenues for research. It suggests that the planet may have received its water from comets or asteroids that impacted its surface, delivering ice to these shadowed regions. Messenger's mission concluded with a controlled descent into Mercury's surface, leaving behind a legacy of groundbreaking discoveries. The data collected by Messenger continues to be analyzed, providing insights that will inform future missions to Mercury and beyond. Section 6. Bepi-Colombo, the journey continues. In 2018, the European Space Agency and the Japan Aerospace Exploration Agency launched the Bepi-Colombo mission. This is the most sophisticated mission to Mercury yet. Bepi-Colombo consists of 2 spacecraft that will orbit Mercury together. The mission is named after Giuseppe Bepi Colombo, an Italian scientist who made significant contributions to our understanding of Mercury's orbit. Bepi-Colombo will study Mercury's interior, surface, magnetic field, and exosphere in even greater detail than Messenger. The mission is expected to last for at least 7 years. Scientists are hopeful that Bepi-Colombo will help us to answer some of the remaining mysteries about this enigmatic planet. Section 7. Can we see Earth from Mercury? So could we see Earth from Mercury? The answer is yes, but it wouldn't be easy. Earth would appear as a bright, star-like object in Mercury's sky. It wouldn't look like the familiar blue and green planet we know and love. The view would be quite different from what we're used to. The sun would dominate the sky, appearing much larger and brighter than it does from Earth. The stars would be visible during the day, but they would be faint compared to the sun's brilliance. Section 8. Keep exploring the cosmos. Mercury is a fascinating world that continues to surprise us. From its extreme temperatures to its surprising magnetic field, this tiny planet holds clues to the formation and evolution of our solar system. As we continue to explore Mercury, we'll undoubtedly make even more exciting discoveries. So keep looking up at the stars and never stop exploring the wonders of our universe.